Alright, here we are back in series parallel circuit faults. This is going to be our section on changed value in the series portion of the circuit. So we're going to start by changing our value of R1. So R1 was 2K ohms and now it is 1K ohms. Now our paths for current don't change. All we start to see are changes in our numbers. So let's start to look first at total resistance. Total resistance was 3K ohms, which was our REQ of 1K, which has actually not changed, and then the combination of that and our series resistor. So it has changed now because our series resistive value has changed. So now we have our REQ of 1K and our series resistor of 1K, which gives us a total resistance of 2K ohms, which is a decrease in total resistance from what we originally had in our series parallel calculations. So now, good chance again to look at Ohm's law arrow theory. If I have voltage that stays the same and resistance that goes down, I see current going up. Alright, so I look over at total current next, and I know that it was originally 4 milliamps, which was 12 divided by 3,000 ohms. Now, of course, we would redo our calculations for that, which is 12 divided by 2,000 ohms. And we now have a current of 6 milliamps, which it has indeed gone up. Alright, so once we've looked at total current, we are going to look at our voltage drop on our series component. We did have 8 volts. We know that's changed because the resistive value of R1 has changed and total current has changed. So we look and we see that 1K, which is the new resistive value of R1 multiplied by our new current of 6 milliamps, gives us a voltage drop of 6 volts. We also see changes on the voltage for our parallel. It was 4 volts. Now it is 1,000 ohms, which is the original resistive value of our parallel, multiplied by the new higher current. So we see a higher voltage drop now of 6 volts. Alright, now that we've got new voltage out on our parallel branches, we can look at the current out on our parallel branches. Originally we had 2 milliamps for branch 1, and that of course has changed. Now we have our 6 volts divided by the 2,000 ohms in the branch, which gives us 3 milliamps. We see the same on branch 2 because we have the same 6 volts applied and the same 2,000 ohms in the branch, and we have another 3 milliamps. So our 3 milliamps in each branch add up to our total current of 6 milliamps, and we know of course that the voltage on our parallel components is constant because voltage in parallel is constant and each of our branches only has one component, so each of them is 6 volts. We also find that our 6 volts in our parallel added to our 6 volts in our series resistor adds up to our total applied voltage of 12 volts. So pretty easy. Changed value for our series component and our series parallel circuit faults. Next we'll look at a changed value in the parallel portion of our series circuit.